For this one, number 7, we're going to just look at those equations of lines that we're going to be drawing in. At this point, I'm hoping that you will be able to use the previous 2 demos to help you perform the reflection itself. For these ones, I just want to think about what does it mean to be a line y equals 2 or a line x equals 1. So on our coordinate plane, remember this is our x-axis, this is our y-axis, and this is going to feel maybe a little bit backwards, but all of my possible x values show up on this line, and all of my possible y values would show up on that line. So if I was trying to go to a position x equals 7, I would be moving right and left. If I was going to a position y equals 2, I would be moving up and down to try to find that point. So when I draw the line y equals 2, I want the position on the graph where regardless of what my x value is, the y value is always going to be 2. So I want to go up 1, 2. That is a y value of 2. So whether I am over here or I'm over here on that line, the y value is always 2. My x value can change, but my y value will always be 2. That is the line that is equal to y equals 2. So this line that I'm drawing in right here, that is y equals 2. Similarly, if I'm going to reflect over the line x equals 1, if the y lines are the ones that are going right to left in that way, for where all of the possible y values are 2, all of the possible x values being 1 would be somewhere crossing that x-axis. So y equals 2 is going to cross the y-axis. X equals 1 is going to cross the x-axis. So in this way, x equals 1 right here, it could be y equals -7 and x equals 1. It could be y equals +3 and y equals 1. Either way, the line that I'm drawing is when x is 1 always for all values of y. I'm going to move this over here so I can actually draw a straight line or straight-ish line. And so this line that I've drawn in would then be x equals 1. So now that we have those lines drawn in, we can perform the reflections in these 2 diagrams.